Phases of optimizations. There are generally two phases of optimization: global optimization and local optimization. Global optimization is nothing but transformations are applied to a large program segments that includes functions, procedures and loops. Local optimizations is nothing but transformations are applied to small blocks of statements. The local optimization is done prior to global optimization. So this is the code optimization techniques. So in that we have common sub-expression elimination, strength reduction, code movement, dead code elimination and compile time evaluation. In compile time evaluation we have again constant folding and constant propagation. So we have compile time evaluation, common sub-expression elimination, dead code elimination and code movement. Compile time evaluation, two techniques fall under compile time evaluation, that is constant folding and constant propagation. In constant folding, as the name suggests, it involves folding of constants. The expressions that contain the operands having constant values at compile time are evaluated. Those expressions are then replaced with their respective results. So for example, circumference of circle is equal to 22 by 7 into diameter. Here this technique evaluates the expression 22 by 7 at compile time. The expression is then replaced with its result 3.4. So this saves the time at runtime. And next one is constant propagation. In this technique, if some variable has been assigned with some constant value, then it replaces the variable with its constant value in the further program during compilation. The condition is that the value of the variable must not get altered in between. So for example, we have pi value is 3.14, radius 10. So the area of the circle is pi into radius into radius. So here this technique substitutes the value of variable pi and radius at compile time. It then evaluates the expression 3.14 into 10 into 10. The expression is then replaced with its result 3.14. This saves the time at runtime. And the next one is common sub-expression elimination. The expression that has been already computed before and appears again in the code for computation is called as common sub-expression. In this technique, as the name suggests, it involves eliminating the common sub-expressions. The redundant sub-expressions are eliminated to avoid their recomputation. The already computed result is used in the further program when required. So for example, consider the code before optimization, that is S1 is equal to 4 into I, S2 is equal to A of S1, S3 is equal to 4 into J, S4 is equal to 4 into I, and S5 is equal to N, S6 is equal to B of S4 plus S5. So this code after optimization, it can be changed as S1 is equal to 4 into I, S2 is equal to A of S1, S3 is equal to 4 into J, and S5 is equal to N, and S6 is equal to B of S1. Here in place of S4 again we have the same thing. So we can write as S1 plus S5. So this is the code after before optimization and this is after optimization. So here if any common sub-expression is there, that is been eliminated and it is written. And the next one is code movement. In this technique, as the name suggests, it involves movement of the code. The code present inside the loop is moved out if it does not matter whether it is present inside or outside. Such a code unnecessarily gets executed again and again with each iteration of the loop. This leads to the wastage of time at runtime. So here consider an example code before optimization. For of int j is equal to 0, j less than n, j plus plus, x is equal to y plus z, a of j is equal to 6 into j. So here after optimization changes as x is equal to y plus z. For int j is equal to 0, j less than n, j plus plus, and a of j is equal to 6 into j. So this changes like this. And next one is dead code elimination. In this technique, as the name suggests, it involves eliminating the dead code. The statements of the code which either never executes or are unreachable or their output is never used are eliminated. So this is the code before optimization. I is equal to 0. If I equal to 1, then A is equal to x plus 5. So the code after optimization is I is equal to 0. So here the code which is not used is being eliminated. And next one is strength reduction. So in this technique, as the name suggests, it involves reducing the strength of expressions. This technique replaces the expensive and costly operators with the simple and cheaper ones. Consider an example code before optimization, that is b is equal to a into 2, and that after optimization we can write as b is equal to a plus a. So instead of using the costly operator star, we can write as a plus a. Here star is the expression a into 2 is replaced with the expression a plus a. This is because the cost of multiplication operator is higher than that of the addition operator.